So now let's talk about the autocorrelation. Again, autocorrelation is the correlation with myself but different time point. So positive correlation is when this one, the previous one is negative. Again, this is a negative. Previous one is positive, and this is positive, 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 and then negative and negative. Actually, out of how many times this changes? 1, 2, 3, 4, 5, 6, 7, 8. So 8 steps. Out of 8 steps, only 2 times change the sign, right? Other than that, so 6 steps is maintained the same sign with the previous data, right? So that's what we call is a positive. If there is a tendency, the last one was a positive and then current one has a positive, more likely to be a positive. Last one is negative and then more likely our current one will be the negative. But negative correlation is this one is minus and next one is plus, minus and plus to the minus, minus to the plus and plus to the minus, minus to the plus, plus to the minus. So actually this is a 1, 2, 3, 4, 5, 6, 7, 8 step. All of the 8 step, right? Opposite sign. So this is like a negative correlation because every time depends on the. So this is what we call the autocorrelation. What is this variable? Is the same independent variable. So it has a correlation with itself. That's why we call this is autocorrelation, but different time point. So same as a different independent variable has a high correlation, then we cannot rely on the coefficient calculation, right? So same way, if we have a high correlation, autocorrelation, when we calculate the time series regression, we cannot trust our calculation of the coefficient. So we have to avoid, but how can we measure? So this is the Durbin-Watson test, which is usually called the DW test. And then force over correlation, we calculate this way. And this is the correlation coefficient. Z is again, this is like error term. So what is the relationship with the previous data error versus the current error? So hypothesis test is the row. This row is 0. Is 0 means it doesn't have any relationship. So error of current error doesn't have any effect by the previous error at all. If this is not 0, which means it's affected by the previous error, so it may have a autocorrelation. So this test statistics is calculating this one, difference between the current error and the previous error, and then each error's square, and we calculated this is the D. So when there is no correlation, E times E t minus 1 is a current error times previous error, and there's a sigma, so adding up. So if there is no correlation, sometimes you have a positive number. This multiplication can be positive if they have the same sign, or they have a different sign, you have a minus. So you will have a bunch of positive and bunch of negative. So if you add up, it will be 0 if you have no autocorrelation at all. No autocorrelation means there's no tendency of the sign, the current one, with the previous one, right? So you will have about same number of positive, same number of negative, so this error will be 0. Then you will have only this one and this one. But what is the difference? This is just a summation of all time period. So t and t minus 1, so basically these two things are the same thing, right? So adding these two and then divide by the same thing, so you have a 2 sigma e to the over the sigma over e t squared. It's just 2. So 2, if you have a d as a 2, then you can say this is a no correlation. What if there's a perfect positive correlation? So always they have the same sign. So what will happen is it's the same sign. Since the expected value of e is not square, e is the 0, actually we don't have to worry about the scale. As long as this case is whenever this is minus, this is minus. Whenever this is positive, this is positive. So we will have always the positive number, right? So e will becomes the e square of the t because I'm adding all of them, and because it's minus 2, so you have a sigma e square minus 2 sigma e square plus sigma e square. All of this will be gone, and then you will have a 0. So when these 0, you have a perfect positive correlation. So remember, when the autocorrelation, there's no autocorrelation, rho is 0, you have a 2. When you have a positive correlation, the test statistics is 0. And when you have a negative autocorrelation, your d will be the 4. In this case, always has a opposite sign. So whenever you multiply the current one and the previous one, you will have always has a minus. And there is a minus term also. So if you just add up the sigma of the e square, minus 2 times minus, right? Sigma of minus e square, so this will becomes plus sigma of e square. So altogether this is a 4 sigma e square. And then we have a denominator is a e square sigma e square, so it will be 4. So you can see it as a d can be moved to 0 to the 4, and 0 case is a perfect positive correlation, and 4 means it's a perfect negative correlation, and 2 means you have a 0 correlation. So DW test, actually 0 means it's a positive, this is a perfect positive, and this is a perfect negative, and then we want to have a 0, no autocorrelation, so it should be close to the number 2. But there's a like a upper limit or the du and dl, and using this one we can actually create the area. Inconclusive means is I cannot tell it's a positive or I cannot tell it's no correlation. So we cannot make a decision here, but here is all number 4 in between here. I can tell it's a no autocorrelation. Here is a positive, and here is a negative autocorrelation. How can I find out dl and du? Is you can just click this link, and then you will find out how you can find the du and dl. But same as our z statistics or t statistics, we don't want to take a look at what is the critical point value. So instead, we will get a p-value, so we can just simply tell according to the p-value, and we can say, okay, there is no correlation or there is correlation. You will see how we can get the DW test. Again, yeah, of course, we will not calculate this one by hand. So we can use R, the car library. If you bring the car library and then you run the regression model using the 1, 2, 3, 4, the time series, and then you can use the Durbin-Winston test. Actually, if you use a different library, you can do the DW test. So I will show you, but result will be the same. Again, we will get a t-statistics. This is can we say this is the close enough to the 2? We will look at the p-value. So when we use like a 0.05, 5% confidence level, since this is smaller than 0.05, we can reject the null hypothesis, and then we can say, yeah, rho is not 0. So the p-value is smaller than the critical point, so we can reject null hypothesis. So this is true. So rho is not 0, which means it's E of t is times rho of the E t minus 1 plus error, right? This is another error of error. So if this is not 0, then which means there is some relationship. So if the result is come out like this, since we reject the null hypothesis is rho equals 0, but actually rho is not 0, so we cannot say there is no autocorrelation. The result will be there is autocorrelation. And this is like a smaller side. Again, 2 is the no correlation, 0 is the positive correlation, 4 is the negative correlation, 1.27 is around here. So we have a positive autocorrelation. So we should reject the null hypothesis. There is no autocorrelation. Dummy variable in the time series is actually this is the dummy for the World War II. This is the World War II period or not, right? As we already know, the dummy variable, when you put it in the dummy variable, we will have a two separate regression curve, right? So regression curve for the non-World War II period regression curve, and then another regression curve for the World War II period. Since we don't have the intersection part, actually this one will affect the only this intercept. So this one is the fertility rate was a temporarily low. Well, the temporary is important. That's why we have a different curve. But when there's no the World War II area, then you will have a different curve.